Good morning everyone. Today we will be presenting our project on measurement of dataran cendekia at UiTM Shah Alam using the least square method. This presentation is prepared by Sharifah and myself ARINA, and we are presenting this as a part of our Mat 575 course under the guidance of Prof. Madya TS Dr. Muhammad Agus. In this section, we will show you a video demonstrating the data collection and the application of the least square method by fitting a curve to the measurement data of dataran cendekia. The least square method is a mathematical technique used to find the best fitting curve for a set data points by minimizing the sum of square difference. In this project, we apply this method to measure the large and irregular space of dataran cendekia. This method helps reduce the errors typically found in traditional measurement approaches and making it more accurate and efficient alternative. So for the problem statement, traditional measurement method for large space like dataran cendekia are prone to errors and inefficiencies. These methods are often time-consuming and inaccurate, especially when measuring irregularly shaped areas. To address this issue, we propose using the least square method as a more reliable alternative for such measurement. So, for the objective of this project are to apply the least square method to approximate the measurement of dataran cendekia, and second, to compare the accuracy of the least square method with traditional measurement method, and third, to demonstrate the practical application of this method for large-scale measurement, which can be beneficial for future urban planning and civil engineering project.
Now, we move to graph explanation. We started by collecting data using Google Maps, where we scaled the maps to a 2 cm equal to 50 feet ratio. Based on the scale I mentioned just now, we measure the circumference of dataran cendekia, which come out to be 65 cm on the graph, equally 1,625 feet in reality. As you guys can see, the graph has been plotted into 18 points and has been divided into 6 equations. This graph helps us visualize and process the data for the next step in the curve fitting process. So, this is the formula that we use to fitting the data. So, next is the implementation part, curve fitting. In order to apply the least square method, we follow a series of steps. So, for step 1, we first calculate the sum of the required value based on the data points. We calculate the sum of x, y, x squared, x cubed, x to the power 4, xy, and x squared y. Step 2, we then substitute the sum into a metric form to set up the normal equation. And the number 1, 2, 3 in this slide is to indicate the equation 1, equation 2, equation 3, and so on. After that, we calculate the coefficient A node, A1 and A2 using the metric to solve the best fitting curve. Step 4, the coefficient we got just now from step 3 will substitute into the polynomial function, and we differentiate the function for arc length calculation. Finally, for step 5, we calculated the arc length using the formula, and we got arc length for equation 1 is 9.8021, equation 2 is 11.0227, equation 3 is 9.2921, equation 4 is 11.6216, equation 5 is 7.2889, and equation 6 is 10.1896. For your information, arc length is a crucial part of understanding the space measured by the curve. This allows us to compute the total arc length of the fit curve by additing all the arc lengths of each equation, and we got 59.2170 cm, which is this is the approximate value that we will use for error analysis later. And by calculating total of arc lengths, it will give us a better estimation of the real world measurement of dataran cendekia. Next is error analysis. To evaluate the accuracy of our result, we perform an error analysis. We are calculating 3 types of error. First one is absolute error, the difference between the true value and the estimated value. Next is relative error, the ratio of the absolute error to the true value. And the last one is percentage error, the relative error expressed as a percentage. The percentage error in our project was 8.90%, which is indicate that while the method was effective, there is room for improvement.
For the conclusion, the least square method proved to be an effective tool for measuring dataran cendekia, offering a more accurate solution compared to traditional methods. However, our error analysis showed a relative error of 8.90%, suggesting that further refinement of the model could improve its accuracy. We recommend using this method for large-scale measurement project, especially in urban planning, civil engineering, and data analysis. I think that's all from me, and thank you for your attention. We are happy to answer any question you may have.